Sunny and you ask me Parishan and then to this video, I will teach you what is inside this charger. Now look at the table. This is a 3.5 amps charger which is model number is mt385, which is a local charger made by MT, which is worth 220 volts, 240 volt input and output is 25 volts with 3.5 gigafast charger. Now see what is inside. So first open the charger, we need a screwdriver kit, and we need a flathead screwdriver because it's open in flathead. Now take this one. Now this time there are two lids. There are front lid and back lid. So I think this front lid is not open easily. We open a back lid first to reveal the circuit. Reveal the inside. Just I put them and there it contains some lots. Which lots you can easily open by yourself, because it is very easy to open. You can lock if you overforce them. If next time on rejoinable because it is closed. But in my case this charger is not working, so it is not matter. It's both lots are open in my case right now. But I still use this body made up from my own charger. So right now it's over like that and like that, and it's come out. There inside a circuit board which contains rectifier, draining MOSFET, two diodes for outputting, and some these diodes for I think feedback, and there are two resistors, one diode there and one diode there, there is resistor and there is feedback, and there is one resistor more. And other thing is the other circuit is the back side of this board. Now try to open a back side. I don't think back side is easily come out, but still we try. I'm 100% no, back side is not easily come out this moment because it is thin or blue. Remove circuit to open this side and see front side of circuit board, and other option is that to remove. Another option is that to remove the entire board out, which I also do to reverse engineering. And now what we tend to do, it is very easy like that, and it's come out. This is a glass. There contained capacitor, feedback capacitor, transformer, ceramics, and output capacitor, and some resistor there which is a fusible resistor. Now it's time to move up entire board, which says we remove these clips carefully like that, both the sides, and I think board is come out. If it is not come out easily, then we can touch the plastic body. But line of my plans is to shape the body because I later use it for my own charger making, and I so move that, and this board is come out, this wire come out, and now it's put it aside. There's contains 4 LEDs, this input resistors, capacitor, feedback capacitor, output capacitor, ceramic capacitor, and there is a one transformer and this 4 LEDs, and there is a output capacitor, and then rectifier capacitor and magnetic diode, and there is two 4 resistors and 5 resistors. Now it's time to reverse engineering and complete the video. Pause. And I am one thing further to mention, there are nuance difference between primary and secondary isolation. So you can see this is a primary section like here, and these are the secondary section. So there is no any patient, they use tiny little gaps, but not too much, because this gap can handle maximum 1000 volt. For some reason, if charges that input voltage is too high, it will easily short circuit the charger and burn your cell phone. That power gap or space between primary and secondary saturation, so that's why it is. I say it is not safe to use them. And now this is already write it down. Line those fuse able resistors, which is 0.33 ohms, to the rectifier, and rectifier positive goes to a port 100 volts, 10 microfarad plus positive, and negative of the plus negative, and this is and positive goes to a transform primary winding one terminal, other terminal a snubber network which is made of 8 diodes and 100 kilo resistor and 1 kilovolt capacitor to made of snubber network which can remove the spikes which spike when the off position it cannot come out. And the feedback in winding one terminal is to the ground of negative inside. And these MOSFET ICs which is C550-180-681 is IC which IC I know I cannot find any data sheet of this IC. So these IC is connected. 7 is connected to the negative terminal, 5, 6 is connected to the primary side, and pin number 4 is connected to a 1.8 ohm resistors to a negative. So basically voltage flows to negative to 1.8 ohm resistors in parallel to as a current shunt to the pin number 5 or 6 to turn on this primary winding, and once this primary winding is turned on and repole gives a spike which spike and intensely charged by these number network, and this feedback winding is a feedback system which can connect one terminal ground, other terminals to the resistors, 3 ohm resistor which can power charge this capacitor, and once this capacitor charged, it can pass to a diode to the IC to turn on the IC first time, self start time. Once it starts, it can get a feedback winding voltage state by feedback winding by seeing this feedback coil to charge the capacitor, and then diode to the IC to turn on the IC. IC pin number 2 is not connected. Once it's generates magnetic field there, it sends those output externally. One terminal 4 LED negative as well as 1000 microfarad 10 volt capacitor negative as well as 3 USB port negative, and positive connect to the 2 diodes SS34, which 2 diodes contain, one diode contains 2 LED and other diode contain 2 LED parallel with 1 kilo ohm and 1 kilo ohm resistor to limit the current, and then it's turned to the USB. Before that, there are capacitor between these two terminals. I called it to draw, but I draw in and 1000 microfarad 10 volt, which can smooth the voltage, and if you turn limit to the phone turn limit, these two resistors, and these data pins are shorted together to put the phone in enable mode. And now you can see this is circuit first. Fuse rectifier, this is smooth, then goes charger capacitor limited by mt3 micro, and then once its capacitor is charged, you can turn on the IC, which then generates a switching there, and then switching is produce spikes which spike and cancel by this snubber network, and this switching produce voltage there, which voltage then recharge the capacitor and turn on continuously IC. And the transformer primary voltage, primary turn is measured by these, I can measure by these 1.8 ohm resistors. Output goes negative for all these circuits common, which contain 4 LEDs, 3 USB jack and 1000 multiplied capacitor, 10 volt, negative and positive LED supply. Other terminal supplied by SS34 diodes, where each diode pair of two LEDs and another diode pair of other LED plus 1 kilo capacitor, 1000 multiplied 100 volt, and then plus 2 1 kilo resistor, and then these jacks, and then extend output to your phone. And this is small little circuit. And this video is going to be the next video very soon. Pause.